Welcome back. This is lesson 3.1, Why Ambiguity Kills Accuracy. I'm Dr. Song. You just finished module 2. You can run few-shot, chain of thought, templates, recipes, artifacts, and at the very end of module 2, you hit the ceiling on purpose. And one of the cracks that came out of that demo wasn't even on the 4-crack slide, a silent factual error inside Polish prose. This module is the direct fix for that fifth crack. By the end of Module 3, you'll write prompts that make silent errors hard. By the end of this lesson, 3.1, you'll understand why those errors happen in the first place. Let me replay what happened in 2.5. You wrote Claude a prompt that included, in the setup, the phrase 15% savings if paid upfront. Claude wrote you back a warm, confident email that repeated 15%, and the customer reading that email would have believed it. $200 a month drops to $150 a month. 200 minus 150 equals 50. 50 divided by 200 equals 25%, not 15. The arithmetic was trivially checkable from the numbers already in your prompt. You didn't catch it. Claude didn't catch it. The email read confident, and confident reads as evidence. That single failure, a wrong number handed down a chain of polished prose, is the failure mode Module 3 is built around. Here's a rule I live by when I'm using AI on anything that matters. If I run the same prompt 3 times in fresh sessions and get 3 different answers, the prompt is the problem, not the model. 3 wrong variants is a property of the ambiguity I left in my words, not of the intelligence on the other side. The pattern that first made this obvious to me was a multi-step earnings projection. Project next year's numbers, assuming revenue drops 15%. Some cost lines should scale with revenue. Some stay flat. I didn't spell out which was which. 3 runs, 3 different answers. Each fluent, each confident, each splitting the costs a different way. The ambiguity was mine. The AI guessed, the guesses differed, and the pros concealed that they differed. Fluency and truth come out of 2 different machines inside the model. When they agree, you get a great answer. When they disagree, you get a confident, wrong one. A warmly worded sentence about a 15% savings is just as warmly worded when the number is wrong. Ambiguity, not typos, not weird syntax, just unspecified meaning in your prompt is what makes the fluency machine and the truth machine disagree. The model has to guess what you meant, and it guesses confidently. 2 things can happen from that guess. 1. The subtle error. Claude interprets an unspecified piece of your prompt one way when you meant another. The answer that comes back is internally consistent, which is what makes it dangerous, but points at the wrong thing. The 15% email is a subtle error. You handed Claude the wrong number. Claude propagated it faithfully. The resulting prose was internally consistent with your prompt and externally wrong. 2. The confident hallucination. Claude fills in a detail you didn't specify, a date, a policy, a citation, a dollar figure, and writes it as if it had been in your prompt all along. The fill-in is fluent. It is often wrong. You did not catch it because you never asked for it. It arrived inside a sentence you did ask for. Same root cause in both. Unspecified meaning in the prompt, different surface, same fix. Those are 2 failure modes of the same cause. There's a third, the one that gets business professionals burned most often, because on the surface it doesn't look like a failure at all. 1. Ambiguity lets the model guess silently. Ask for return on assets without naming ending balance or average balance, and Claude picks 1. Sometimes the guess matches what you needed. Sometimes It doesn't. Either way, Claude doesn't flag that it guessed. 2. Expertise asymmetry raises the stakes. You use AI in the domains where you are least expert. That's the whole point of this course, to extend your reach. But those are exactly the domains where you can't tell ending balance ROA from average balance ROA on site. So when a reviewer, a boss, or an auditor asks why you used that denominator, you have no answer. The prompt never made it a choice you owned. 3. Defensibility is a property of your prompt, not of the answer. Even when the number is right, if the prompt didn't name the choice, you can't defend the number. The rest of this module is about making every choice in the prompt explicit enough to own and defend downstream. Pause the video. Write one sentence about a time Claude handed you a confident wrong answer. What did Claude say, and what was actually true? When people first notice this failure mode, they try 3 fixes. None of them are the right one. 1. Reprompt harder. You read the wrong answer, get annoyed, and send a sharper version of the same prompt. The second answer is usually cleaner, and often still wrong in a different way, because the underlying ambiguity is still there. You've asked Claude to try harder with the same unspecified question. 2. Accept the fluency. You skim the answer, it reads polished, and you ship it. This is how wrong numbers make it into client emails. The pros didn't fail you. Your scheme did. 3. Skip verification entirely. You assume the next version of the model will fix this. It won't. Fluency and truth have been two machines since the first language model. They will still be two machines when the next model ships. The model can get better at both, and the gap between the two will remain the load-bearing risk. The right fix is upstream of all three, tighter prompts, less unspecified meaning. That is the rest of this module. Lesson 3.2. The four sources of ambiguity. RSCA. A full-family diagnostic I built from watching specific failure patterns in my evaluation work. Not an industry standard, just the grid I keep coming back to. Reference, which period and baseline. Scope, what's included and what scales. Chain, the sequence of steps and the direction you are solving. Answer, format, units, precision, signs. Lesson 3.3, the 8 disambiguation moves plus the subtask ladder. 2 moves per family. And when a Titan prompt still fails 3 runs in a row, you don't rewrite. You decompose it into 2 or 3 subtasks, add a targeted hint, and try again. Lesson 3.4, State back, engineered uncertainty, and the 3-run check. Make Claude restate its interpretation before answering. Make I don't know an acceptable output. And run the same prompt 3 times in fresh sessions to test whether you actually removed the ambiguity. Lesson 3.5 closes the loop with a personal audit checklist you'll carry into every module after this one. Before the next lesson, do this. 10 minutes. Step 1. Open a Claude conversation from your own past work, any domain. Scroll until you find an answer Claude gave you that was confident and on closer inspection factually wrong. A number that didn't check out, an invented date. A quoted policy Claude couldn't have had, a citation of a paper that doesn't exist. Step 2. Write 1 paragraph. Quote what Claude said. Quote what was actually true. Name, in 1 sentence, which piece of your prompt was unspecified enough to let Claude guess. Step 3. Post the paragraph to the Week 3 discussion board. Coming up, Lesson 3.2, The 4 Sources of Ambiguity. We turn the cold open of this lesson into a 4-family diagnostic grid You can apply to any prompt in under a minute. See you there.